All right, hello everybody again. This is your Pythagoras test, grade 9 simple Pythagoras test. We didn't go too complicated. We just went with the basics here. And we have 9 questions, all of which kind of ask you, do you understand the basics of Pythagorean theorem? The first 3 questions are estimation of non-perfect square roots. The square root of 18 doesn't actually exist in the world because it's an irrational number. But if I was to place it onto a number line that did have perfect squares, like the square root of 16, which is 4, and the square root of 25, which is 5, we know just from this number line that the square root of 18 has to lie somewhere between the square root of 16 and the square root of 25. It's much closer to 16, so I'm going to say roughly right where that red dot is. And therefore, I'm going to estimate the square root of 18 is approximately 4.2 or maybe 4.3. That's perfect for an answer. If you checked your answer with a calculator, you would say that it's actually 4.2. But if you said 4.3, I'm okay with that. Square root of 109 is an irrational number, but the square root of 100 is 10. And the square root of 121 is 11, so we know that it has to fit between there. Slightly closer to 10, but not greatly closer. So therefore, I'm going to guess the square root of 109 is going to be roughly 10. They're right in the middle would be 10.5. 10.4, I'm going to guess. Take your calculator. What is the square root of 109? It's 10.44. Good guess. And finally, the square root of 26 is the square root of 25 would be 5. Square root of 36 would be 6. So therefore, it's right here, which I'm going to guess the square root of 26 is approximately 5.1, maybe 5.2. When I took my calculator, I'd be like, oh, I didn't realize that. The square root of 26 is actually 5.09, which is 5.1. And that's the work you need to show. Here it gives you a triangle. It says 2, 3, 5. Is this a right triangle? If it is, it follows Pythagoras. So if I was to attach squares to all of these, since the side length is 2, the area of the square would be 4. Since the side length is 3, the area of the square would be 9. And if it is a right triangle, then the area of this square plus the area of this square, or the legs of a right triangle, those areas square, should equal this. But since this is 25, 4 plus 9 does not equal 25. 4 plus 9 does not equal 25, and therefore, no, it's not 90 degrees. It's not a right triangle. Because if it was, this area plus this area would equal this area, but it doesn't. In our next question, we have a right triangle, so if I put my little squares here again onto the sides of this right triangle, the area of this square is 25 because 5 is the side length. The area of this square is 64 because its side length is 8. 25 plus 64 is 89. Therefore, if the area of that square is 89, then its side length must be the square root of that. So therefore, x is equal to the square root of 89. And x is approximately equal to, if I was to estimate that, I'm going to guess 9.4. I have no idea. Let's just double check. Square root of 89. Square root of 89. Oh, that's the wrong button. Ah! Mercy. Square root of 89. 9.43. Yeah, that's good. Notice how I said is equal to and is approximately to, because the square root of 89 is the actual length, but since it's an irrational number, the square root of 89's approximate value is 9.4. Slappy some squares on here. This is going to be an area of 25. This is an area of I don't know. This area of 64. This plus this equals this. So 64 take away 25. Well, 65. So 4 take away 20 is 44. Take away 5 more is 39. Therefore, x is going to be equal to the square root of 39, because this area is 39. Or x is going to be approximately equal to, since the square root of 36 is 6, I'm going to guess 6.3, but I think I might be a little high on that. Let's just see. Square root of 39. Oh, that's the wrong number. Square root. 6.24. Yeah, it's closer to 6.2 than 6.3. All right, now we get into the questions that befuddled and betwixt many people. The first question is your standard Mr. Connell versus Mr. Bridges. Mr. Connell ran around the perimeter of the room. Mr. Bridges ran over to this corner and then cheated and ran across the diagonal of the gymnasium. Mr. Connell ran farther, but the question is how much farther did Mr. Connell run? So Mr. Connell ran 2/8, or actually the perimeter of a rectangle. I can actually give you the actual formula. The perimeter of a rectangle is 2 lengths plus 2 widths, or 2 lengths plus 2 widths. So therefore he ran 2 eighths, and he ran 2 tens, or 16 and 20. Therefore, Mr. Connell ran 36 meters if he ran around the entire gym. He ran 8 and 10 and 8 and 10. Right? Mr. Bridges, on the other hand, ran an 8 and a 10, and this diagonal here. And that diagonal there, if I was to trace this here and bring it down, is actually, that's the one I want to bring it down with, is actually a right triangle. So that right triangle, or that horizontal, or that diagonal distance, is going to be the hypotenuse of this right triangle. This is 64 area. This is 100 area. So this area here of this hypotenuse would be, therefore, 164. And the distance, or the length across the diagonal, will be the square root of 164, which is going to be, I think, 12.8 maybe. Let's see what it is. 164 square root, 12.8. Approximately 12.8. So therefore, Mr. Bridges ran 8 and 10 and 12.8, which when I erase all this stuff is going to be 30.8 meters. But the question is, how much farther did he run? Well, 36 take away 30.8 equals 5.2 meters more. Therefore, Mr. Connell ran 5.2 meters more than Mr. Bridges. Okay, I'm going to go on to the next one. So if you want to pause it now to copy it. And off we go. Next question. It says the perimeter of the square is 80. What is its area? Well, since perimeter is equal to, in a square, 4 side lengths. 1, 2, 3, 4. That's the distance around, or the perimeter. 4 multiplied by whatever the side length is. Then if I solved it algebraically, then the perimeter, which we know to be 80, is equal to 4 sides. And if I solve this using very basic algebra, divide both sides by 4, I would solve it. 20 is the side length, which makes sense, because 20 plus 20 plus 20 plus 20 is 80, which is the perimeter. So we now know that the side length of this rectangle is 20. And then it says, well, square, sorry, not rectangle, not triangle, is 20. What is its area? Well, the area of a square is side squared, or 20 squared, or 20 times 20, which means if the side length of a square is 20, its area must be 400 square meters. And that's the answer. A square that has a perimeter of 80 has an area of 400. The last question reverses it. It says the area is 50. So area equals side squared, or 50 equals side squared. If I square root both sides, the side length of a square whose area is 50 is approximately 7.1. Because if I grab my calculator and say, what is the square root of 50? It says 7.07, which is roughly 7.1. So now we know that the side length of the square is 7.1, and its perimeter will be equal to 4 multiplied by that, or the perimeter will be 4 7.1s, because it'll be 7.1, 7.1, 7.1, 7.1, which the perimeter therefore would be 28.4 meters in length.